What if I told you that every photon of light traveling through the universe isn't just energy, but information being processed by reality itself? What if the cosmos is literally reading light the same way your computer reads ones and zeros? Right now, as you watch this video, trillions of photons are hitting your retina. You think you're just seeing colors and shapes. But here's what will blow your mind. Those photons have traveled millions, sometimes billions of years through space, and the universe has been extracting information from them the entire journey. Not metaphorically, actually. In 2022, physicist Melvin Vopson at the University of Portsmouth published something that shook the foundations of physics. He calculated that information has mass, actual measurable mass. He called it the mass-energy information equivalence principle. If information has mass, and light carries information, then light isn't just electromagnetic radiation moving through empty space. It's data packets being read, processed, and stored by the fabric of spacetime itself. This isn't science fiction. This is cutting-edge physics that's forcing us to reconsider everything we thought we knew about reality. By the end of this video, you'll never look at light the same way again. You'll understand why some physicists now believe we're living inside what might be the universe's ultimate data processing system. And the implications? They're absolutely staggering. But before we dive into this rabbit hole, do me a favor. If this concept already has your mind spinning, hit that like button right now. And subscribe, because this journey gets so much deeper than you can imagine. Also, drop a comment telling me which country you're watching from and what time it is where you are. I'm genuinely curious how far across the globe this information is traveling right now. Think about that irony for a second. Let's start with something that seems simple but isn't. What is light, really? You learned in school that light is electromagnetic radiation. Waves of energy oscillating through space at 299,792,458 meters per second. That's technically correct, but it's like describing the internet as electrons moving through wires. You're missing the entire point. Here's the surprising twist that most people never learn. Light has a dual nature. Sometimes it behaves like a wave. Sometimes it behaves like a particle. This isn't a bug in our understanding. It's a fundamental feature of reality, proven by Thomas Young's double-slit experiment in 1801, and later confirmed countless times in quantum mechanics experiments throughout the 20th century. But here's where it gets weird. When light behaves like a particle, we call it a photon. And photons don't just carry energy, they carry information. Specific, quantifiable information about where they came from, what they've interacted with, and what state they're in. Think of it like this. Imagine every raindrop that falls contains encoded within it the complete weather pattern of where it formed, the temperature at every altitude it passed through, and every surface it touched. That's closer to what photons actually are. They're not just particles of light. They're data packets. In 1905, Albert Einstein won the Nobel Prize not for relativity, but for explaining the photoelectric effect using this particle concept of light. He showed that photons carry discrete packets of energy proportional to their frequency. Energy equals Planck's constant times frequency. E equals hf. This simple equation revealed that light comes in quantized units, digital units, like bits of information. Now, let's talk about something revolutionary that happened in quantum mechanics. When physicists started studying how photons interact with matter, they discovered something mind-bending. The act of measurement changes the photon's state. Before you measure a photon, it exists in what's called a superposition, holding multiple possible states simultaneously. When you measure it, that superposition collapses into a single definite state. This is the famous observer effect, and it's been confirmed by thousands of experiments. But here's what most explanations miss. The collapse of the wave function is fundamentally an information transfer event. The universe is extracting specific information from the photon and updating reality accordingly. The photon isn't just being observed, it's being read. Let me give you an analogy. Think of your smartphone screen. When you're not looking at it, the pixels exist in an indeterminate state, waiting to display whatever information is called upon. The moment you open an app, specific pixels activate with specific colors to convey specific information. The screen doesn't create that information from nothing. It reads it from memory, processes it, and displays it. What if the universe works the same way? What if space-time itself is reading photons, extracting their information content, and updating the state of reality frame by frame? This might sound like wild speculation, but let's look at what modern physics actually tells us. In quantum field theory, particles aren't really particles at all. They're excitations in underlying quantum fields that permeate all of space. A photon is an excitation in the electromagnetic field. When that photon interacts with an electron, information is being transferred between fields. The universe is processing that interaction. And here's the kicker, that processing follows mathematical rules, precise, computable rules. The Schrödinger equation, the Dirac equation, Maxwell's equations. These aren't just descriptions of reality. They're algorithms, literally. They're computational processes that the universe follows to determine what happens next. So if light carries information, and the universe processes that information according to mathematical rules, what happens to that information when light disappears? This question led to one of the biggest controversies in modern physics, the black hole information paradox. In the 1970s, Stephen Hawking discovered something shocking. Black holes aren't completely black. They emit radiation, now called Hawking radiation, through quantum effects at their event horizons. And over unimaginably long timescales, black holes eventually evaporate completely. Here's the problem. When something falls into a black hole, all its information seems to vanish behind the event horizon. If the black hole then evaporates, that information would be destroyed forever. But quantum mechanics says information cannot be destroyed. It can be scrambled, encrypted, or hidden, but never erased. This paradox consumed the world's greatest physicists for decades. Stephen Hawking, Leonard Susskind, Gerard 't Hooft, and dozens of others battled over whether information is truly lost or somehow preserved. The resolution? It's mind-bending. The information falling into a black hole isn't destroyed. It's encoded on the black hole's event horizon. The entire three-dimensional information content of everything that fell in, it's written onto a two-dimensional surface, like a hologram. This is called the holographic principle, proposed by Gerard 't Hooft in 1993 and expanded by Leonard Susskind. And here's where it connects to our question about light. If information can be encoded holographically on a two-dimensional surface, and if light carries information, then every photon interacting with spacetime might be writing information onto the fabric of reality itself. Let me give you another analogy. Think of a CD or DVD. The data on these disks is encoded as microscopic pits and lands on a flat surface. When you shine a laser through them, the light reads those patterns and converts them back into music or video. The three-dimensional information of a movie is stored in a two-dimensional pattern and reconstructed by reading it with light. What if spacetime works fundamentally the same way? What if every surface in the universe is constantly encoding information holographically? And photons are the universe's way of reading and writing that data. This isn't just theoretical anymore. In 2017, a team of physicists at the Technical University of Vienna actually demonstrated holographic encoding of information in light beams. They showed that you can encode enormous amounts of data in the quantum states of photons, far beyond what conventional physics predicted. But here's what will really blow your mind. The amount of information that can be stored on a surface is proportional to its area, not its volume. This is called the Bekenstein bound, named after physicist Jacob Bekenstein, who calculated it in 1981. For any given region of space, there's a maximum amount of information it can contain, and that maximum depends on the area of its boundary. This suggests something profound. Reality might be fundamentally two-dimensional, with the three-dimensional world we experience being a projection, a hologram, constructed from information encoded on distant boundaries. And light? Light is how that information propagates through the projection. Photons aren't traveling through space. They're updating the hologram frame by frame. If the universe reads light like data, then the universe must be performing computations. And if it's performing computations, how powerful is this cosmic computer? In 2002, MIT physicist Seth Lloyd published a groundbreaking paper calculating the computational capacity of the universe. He determined that since the Big Bang, the universe has performed approximately 10 to the power of 120 operations on roughly 10 to the power of 90 bits of information. To put that in perspective, if you took every computer on Earth, had them running at maximum capacity since the beginning of human civilization, they wouldn't even approach an infinitesimal fraction of the computational work the universe has done in just the last second. But here's the fascinating part. Lloyd showed that this computation is happening at the quantum level. Every particle interaction, every quantum state change, every measurement is a computational operation. The universe isn't just like a computer. At its most fundamental level, it is computing. And light plays a special role in this computation. Photons are massless, which means they can propagate information at the maximum possible speed, the speed of light. They're the universe's fastest communication channel. They're literally the bandwidth of reality. Think of it like this. Your computer has a processor that performs calculations and a bus that moves data between components. The processor's speed is measured in gigahertz. The bus's speed is measured in bandwidth. Light is the universe's data bus, carrying information between quantum processors, particles, and fields at the ultimate speed limit. Now, here's where quantum computation comes in. Regular computers process bits that are either 0 or 1. Quantum computers process qubits that can be 0, 1, or both simultaneously in superposition. A photon, with its wave-particle duality and quantum properties, is a perfect natural qubit. In 2020, a team at the University of Science and Technology of China achieved quantum supremacy using photonic quantum computing. They showed that photons can perform certain calculations exponentially faster than classical computers. They weren't building a computer that uses light. They were demonstrating that light itself is inherently computational. But let me connect this back to something more tangible. When you see something, here's what's actually happening. Photons bounce off objects, carrying information about the object's properties, color, texture, shape. These photons enter your eye, interact with photoreceptor cells, triggering chemical and electrical signals that travel to your brain. Your brain then processes this information to construct your perception of reality. But here's the twist. Before the photons reach your eye, they've already been processed by the universe. They've interacted with countless particles and fields. They've been scattered, absorbed, re-emitted. Each interaction is a computation. By the time you see something, the information in those photons has been processed billions upon billions of times by the universe's quantum computational substrate. You're not seeing raw reality. You're seeing the universe's processed output. This has profound implications. It suggests that what we call physical laws, the rules governing how particles interact, how forces work, how space-time curves, are actually algorithms. Computational procedures that the universe follows to process information and determine the next state of reality. And here's the retention hook for you. What if consciousness itself is the universe becoming aware of its own computational processes? What if your awareness right now is reality reading its own code? We'll come back to this, but first, we need to understand how information actually gets encoded in light. Let's get specific about how photons actually carry information. Because when physicists say light is data, they mean something very precise. A single photon can encode information in multiple ways simultaneously. First, there's its frequency, which determines its energy and color. Second, there's its polarization, the orientation of its electromagnetic field oscillation. Third, there's its orbital angular momentum, the way it spirals through space. Fourth, there's its path, which route it takes. And fifth, there's its timing, exactly when it arrives. Each of these properties can carry distinct information. It's like having 5 different communication channels in a single particle. This is called multiple degree of freedom encoding, and it's revolutionizing quantum communication and quantum computing. In 2014, physicist Jianwei Pan at the University of Science and Technology of China used photons to teleport quantum information across 143 kilometers. Not science fiction teleportation, actual quantum teleportation, where the quantum state of one photon is transferred to another distant photon instantaneously through quantum entanglement. But here's what's truly bizarre. When quantum information is teleported, the original information isn't traveling through space. It's not moving from point A to point B. The information at point A is destroyed, and identical information appears at point B. The photons involved are reading and writing quantum information directly to and from the structure of spacetime. Let me give you an analogy that captures how strange this is. Imagine you have a book in New York. You perform some procedure, and the book disappears. Instantly, an identical copy of that book, with all the same words in the same order, appears in Tokyo. The information didn't travel. It was read from one location and written to another location, using quantum entanglement as the communication protocol. This is how the universe handles information. It's not moving particles around. It's reading and writing quantum states. Now, let's talk about something even more mind-bending: quantum error correction. When classical information gets corrupted, like when a file on your computer gets damaged, you lose data. But quantum systems have built-in error correction mechanisms. Quantum information can be encoded redundantly across multiple quantum states in ways that make it recoverable, even if some of those states are disturbed. The universe itself implements quantum error correction. When photons interact with their environment, getting scattered or absorbed, the information they carry isn't necessarily lost. It's encoded in correlations between particles, in the quantum states of fields, in the structure of spacetime itself. This suggests something profound. The universe has mechanisms to preserve information because information is fundamental to its operation. Information isn't something that exists in the universe. The universe is made of information. This idea was first proposed seriously by physicist John Archibald Wheeler in the 1980s with his it from bit doctrine. Wheeler suggested that every physical thing, every it, derives its existence from information, from bits, not bits as metaphor, bits as the fundamental ontological reality. More recently, physicist Vlatko Vedrel and others have developed what's called quantum information theory, which treats information as a physical quantity as real as energy or momentum. In this framework, photons don't just carry information. They are information, temporarily taking physical form. Here's a thought experiment to make this concrete. Imagine you could tag a specific photon with a tracker and follow its journey. That photon might be emitted from a distant star, travel through the vacuum of space for millions of years, pass through interstellar dust clouds, get gravitationally lensed around a black hole, enter Earth's atmosphere, scatter off air molecules, pass through your window, bounce off this screen, and enter your eye. At each stage, information is being exchanged. The photon's frequency might shift slightly due to the expansion of space that's encoding information about the universe's expansion rate. Its path bends around the black hole that's encoding information about spacetime curvature. It scatters off air molecules that's encoding information about atmospheric composition. By the time it reaches you, that single photon has accumulated information history of its entire journey. The universe has been reading that photon state at every interaction point, updating reality accordingly. And now you're reading it too, extracting some tiny fraction of its information content to construct your visual experience. But here's the question that should be bothering you. If the universe is constantly reading information from photons, where is that information being stored? Where is the universe's memory? The answer to where information is stored is both simple and mind-blowing. Space-time itself is the storage medium. In 2019, physicist Chiara Marletto at Oxford University proposed something revolutionary called constructor theory. This framework suggests that physical laws should be understood not as rules describing how things change over time, but as statements about which transformations of physical systems are possible and which are impossible. In this view, information isn't something stored in spacetime. Spacetime is crystallized information. Think of it like this. A hard drive stores information by magnetizing tiny regions of a disk. Different magnetic patterns represent different data. The physical structure of the hard drive, the arrangement of magnetic domains, is the information. Similarly, the geometry and quantum state of spacetime, the way it curves, the values of quantum fields at each point, is information. Einstein's general relativity tells us that mass and energy curve spacetime. The famous equation from Einstein's field equations relates the curvature of spacetime to the distribution of mass energy. But if mass energy and information are related, remember Melvin Vopson's mass energy information equivalence? Then information should also curve spacetime. In 2019, Vopson calculated exactly how much mass information should have. According to his calculations, every bit of information has a mass of approximately 3.19 times 10 to 38 kilograms. That's unimaginably tiny, but it's not zero. And when you consider the enormous amount of information in the universe, this adds up to significant mass energy. Here's where it gets wild. Vopson proposed that this information mass could actually explain dark matter. Dark matter is the mysterious stuff that makes up about 85% of the matter in the universe. We know it exists because we can see its gravitational effects, but we can't detect it directly. What if dark matter isn't exotic particles, but the mass of information itself? Let me be clear. This is highly speculative and controversial. Most physicists are skeptical, but it's a testable hypothesis. Vopson has proposed experiments to measure the mass of information directly by erasing bits and measuring energy changes with extreme precision. But whether or not information explains dark matter, the key insight remains. Information has physical reality. It's not abstract. It's not conceptual. It's as real as atoms and energy. Now let's talk about how light writes information to spacetime. When a photon interacts with a charged particle, like an electron, they exchange information through the electromagnetic field. The photon can be absorbed, transferring its energy and momentum to the electron. Or it can be scattered, changing both the photons and the electron's quantum states. These interactions are precisely described by quantum electrodynamics, and they're fundamentally information exchange processes. But here's the beautiful part. Every single interaction is recorded, not in some external ledger, but in the correlations between quantum states throughout spacetime. When two particles interact, they become quantum mechanically entangled. Their states become correlated in ways that can't be described by treating them as independent objects. This entanglement is information about how the universe's components relate to each other. Over time, as particles interact with more and more other particles, information spreads through an ever-growing web of quantum entanglement. The entire universe becomes a vast network of quantum correlations, with photons acting as the primary information carriers, weaving this network together. This is why light is so fundamental. Photons are the universe's journalists, constantly recording and disseminating information about every event, every interaction, every change. They're creating a distributed record of reality, encoded in the quantum state of spacetime. Here's an analogy. Think of the internet. Information isn't stored in one central location. It's distributed across billions of devices, constantly being updated, synchronized, and propagated through networks. The Internet's topology, which devices connect to, which is constantly changing. Yet information persists, accessible from anywhere. The universe works similarly. Information is distributed across spacetime in patterns of quantum entanglement and field states. Photons are the data packets carrying updates through the network. And the laws of physics are the protocols ensuring information consistency and preserving causality. Now, let me blow your mind with a recent experimental result. In 2022, physicists at Brookhaven National Laboratory successfully created quantum entanglement between photons that had never existed at the same time. They created one photon, destroyed it, then created a second photon, and showed that these temporally separated photons were entangled. The second photon had information about the first photon, even though they never coexisted. How? The information was stored in the quantum state of the intermediate system. The universe read the information from the first photon, held it in a quantum memory encoded in field states, then wrote it to the second photon. This proves that information is being actively stored and retrieved by the quantum substrate of spacetime itself. The universe is reading, writing, and processing light as data, just as we proposed. Now we need to confront one of the deepest mysteries in all of physics, the measurement problem. And understanding this will completely change how you think about observation and reality. In quantum mechanics, particles don't have definite properties until they're measured. Before measurement, they exist in superposition, holding multiple values simultaneously. When measured, the superposition collapses to a single value. This is confirmed by countless experiments. It's not controversial that it happens. What's controversial is why it happens and what measurement actually means. This is the measurement problem, and it's been plaguing physics since the 1920s. If the universe reads light as data, this problem might actually have a solution. Here's the traditional puzzle. A photon can be polarized vertically, horizontally, or in superposition of both. Before you measure its polarization, it doesn't have a definite polarization state. It's in superposition. When you measure it, you get either vertical or horizontal, and the superposition collapses. But what counts as a measurement? Does it require a conscious observer? Does the measuring device count? What about a stray photon that happens to interact with your system? Where do you draw the line between a system in superposition and a system that's been measured? The traditional Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg, essentially said measurement requires a classical measuring apparatus, but it never precisely defined what makes something classical versus quantum. This led to decades of confusion and debate. But here's a different perspective. What if measurement isn't special at all? What if every interaction is a measurement? What if the universe is constantly measuring itself? This view is called quantum Darwinism, proposed by Wojciech Zurek at Los Alamos National Laboratory in 2003. The idea is that certain information about a quantum system gets redundantly copied into many environmental particles, particularly photons. This redundant information becomes objective and classical because it's been repeatedly measured by the environment. Think of it like this. When someone does something noteworthy, one witness knowing about it isn't enough to make it objective truth. But if hundreds of independent witnesses all report the same thing, it becomes established fact. Similarly, when a quantum system interacts with many environmental particles, and those particles all carry the same information about certain properties of that system, those properties become objective and classical. And photons are the primary environmental witnesses. Because they interact with almost everything and travel vast distances carrying information, photons are constantly making measurements, turning quantum possibilities into classical facts. Let me give you a concrete example. When you look at a red apple, countless photons are scattering off its surface. Each photon interacts with electrons in the apple's surface molecules. and each interaction measures certain properties of those electrons, primarily which wavelengths of light get absorbed versus reflected. Because billions upon billions of photons all measure the same information, that the apple reflects red wavelengths, that information becomes objective and classical. The apple's redness isn't created by your conscious observation. It's created by the redundant measurement performed by photons. Your eyes then measure some of those photons, extracting the already classical information that many photons had previously established. This resolves the measurement problem without requiring consciousness or magical collapse mechanisms. Measurement is simply information being copied from a quantum system into many environmental degrees of freedom, particularly photons. The universe is measuring itself constantly through countless interactions. But here's where it gets really deep. If every interaction is a measurement, and measurements extract information, then the universe is constantly reading information from itself and updating its own state based on that information. Reality is a self-reading, self-writing system. The physicist Carlo Rovelli, one of the founders of loop quantum gravity, has pushed this idea even further with his relational quantum mechanics interpretation. He argues that quantum states are not absolute, but relational, meaningful only in relation to other systems. A photon doesn't have a definite polarization in absolute terms. It has a definite polarization relative to a particular measuring system. From this perspective, the universe isn't a single unified system computing a single objective reality. It's a vast network of systems constantly reading information from each other, each constructing their own relational reality based on the information they receive. When a photon interacts with your retina's quantum state becomes correlated with the photon state. Information flows from photon to retina. Your retina now has information about the photon. That information propagates to your visual cortex, to your conscious experience. You're not passively receiving information about an independent external world. You're actively constructing reality through quantum information exchange with your environment. And light mediates most of that information exchange. This isn't solipsism. Other systems are also extracting information and constructing their own relational realities. The agreement between different observers, realities, emerges from the fact that they're all reading information from the same quantum substrate, following the same physical laws. Let's talk about the weirdest aspect of quantum mechanics, entanglement. Because if the universe reads light as data, entanglement is the universe's networking protocol. When two photons are entangled, measuring one instantly affects the other, no matter how far apart they are. Einstein famously called this spooky action at a distance because it seemed to violate his principle that nothing can travel faster than light. But here's the crucial insight Einstein missed. Information isn't traveling between the entangled photons. The information was already shared when they became entangled. Measuring one photon doesn't send a signal to the other. It reveals information that was correlated all along. Think of it like this. Imagine I write a secret message, cut the paper in half, put each half in separate sealed envelopes, and send one to Tokyo and one to New York. When someone in Tokyo opens their envelope and reads their half, they instantly know what's written in the New York envelope. No information traveled from Tokyo to New York. The information was already correlated from the moment I split the message. Quantum entanglement works similarly, except the message is written by the quantum interaction that creates the entanglement, and the splitting happens in the quantum state space, not physical space. But here's where it gets mind-bending. Entanglement isn't just a quirky feature of certain quantum systems. It's pervasive. In 2021, physicist Surya Das showed that quantum entanglement might be responsible for gravity itself. The idea is that the attractive force between masses emerges from quantum entanglement between their constituent particles. If this is true, and experiments are being designed to test it, then gravity isn't one of four fundamental forces. It's an emergent phenomenon arising from quantum information correlations. The universe's geometric structure is literally held together by entanglement, and photons create entanglement. When two photons interact with the same system, they can become entangled with each other. When photons scatter off particles, they become entangled with those particles. Light is constantly weaving an ever-growing web of quantum correlations throughout spacetime. This web of entanglement is information structure. It's how the universe knows which events are related to which other events. It's how causality is maintained. It's how the universe processes information globally while respecting local physical laws. Let me give you an example from recent research. In 2023, a team at the Max Planck Institute for Quantum Optics demonstrated that they could use entangled photons to perform measurements more precisely than possible with classical light. They showed that entanglement provides additional information channels that aren't available to unentangled systems. This suggests that the universe uses entanglement as a computational resource. Entangled quantum states can store and process more information per physical degree of freedom than classical states. If the universe is computing reality from quantum substrates, entanglement is how it achieves computational power beyond what's possible classically. But here's the truly profound implication. If entanglement networks extend across vast regions of spacetime, and if measuring one part of an entangled system affects the entire system, then the universe is fundamentally non-local. What happens here can be instantaneously correlated with what happens on the other side of the universe, not by sending signals faster than light, but through pre-existing quantum correlations. The physicist David Bohm explored this idea extensively in his work on quantum theory and wholeness. He proposed that reality has both an explicate order, the world of separate objects and events we experience, an implicate order, a deeper level where everything is enfolded together in quantum correlations. From Bohm's perspective, photons are how the implicate order manifests in the explicate order. Light bridges the quantum realm of entangled wholeness and the classical realm of separate objects. Every photon you see is bringing information from the quantum depths into your classical experience. Now, here's a retention hook for you. If the entire universe is a web of quantum entanglement, and if that entanglement network processes information, could the universe itself be conscious? Could reality be aware? We'll explore this in detail later, but first we need to understand something even stranger: how light transcends time. Here's something that will fundamentally change how you think about light. From a photon's perspective, no time passes, ever. Due to time dilation effects in Einstein's special relativity, as you approach the speed of light, time slows down relative to stationary observers. At exactly the speed of light, time stops completely. A photon, traveling at light speed, experiences zero time between its emission and absorption, no matter how far it travels. From our perspective, a photon might travel for billions of years across the cosmos. From the photon's perspective, its emission and absorption are simultaneous. Its entire journey is a single timeless instant. Let that sink in. Light doesn't experience time. This has profound implications for information processing. If the universe reads light as data, and if light exists in a timeless state, then information encoded in light exists outside the normal flow of time. When a photon carries information from point A to point B, from the photon's reference frame, the information is simultaneously in both locations. This suggests something startling. The universe's information processing might not be sequential. It might be timeless, with causal relationships maintained through the geometry of spacetime rather than the flow of time. Let me give you an analogy. When you write a computer program, you think about it as a sequence of operations happening one after another in time. But from the computer's hardware perspective, everything exists as spatial patterns of voltage states. The temporal flow emerges from how those spatial patterns evolve according to clock cycles. Similarly, the universe's information processing might fundamentally be geometric patterns in spacetime, with temporal flow emerging from the structure of those patterns. In 1983, physicists James Hartle and Stephen Hawking proposed what's called the wave function of the universe. In their approach, the entire history of the universe, past, present, and future, is described by a single timeless quantum state. Time emerges from correlations within this state, but fundamentally, the universe doesn't evolve in time. It just is, as a four-dimensional space-time structure. If this is correct, then photons, existing timelessly, are reading and writing information to a timeless cosmic data structure. What we perceive as the flow of time is the sequential revelation of this information to our consciousness, which experiences time because we're massive particles, not massless light. Here's a thought experiment that makes this concrete. Imagine you could somehow upload your consciousness into a photon. You'd depart from Earth, travel across the galaxy to a distant star, interact with an alien civilization, and return to Earth. From your perspective, the entire journey would be instantaneous. You'd leave Earth at 3 p.m., travel for what we measure as 10,000 years, and arrive back at Earth at 3 p.m. the same day. No paradox, just timelessness. This is actually related to something called the block universe interpretation of relativity. Einstein's equations treat spacetime as a four-dimensional block where past, present, and future all exist equally. Time is just another dimension, like space. We perceive time as flowing because our consciousness moves through this block, but the block itself is static and timeless. If the block universe is correct, then the universe isn't computing reality step by step through time. The entire computation already exists as a geometric structure in four-dimensional spacetime. Photons, being timeless, have direct access to this entire structure. This might explain something mysterious about quantum mechanics. Retrocausality. Some interpretations of quantum mechanics allow for future events to influence past events, not by sending signals backward in time, but because the past and future are entangled in the timeless quantum state. In 2017, physicists demonstrated a phenomenon called quantum time flip, where the order of two operations becomes quantum mechanically indefinite. The system exists in a superposition of operation A, followed by operation B, and operation B, followed by operation A simultaneously. Time order itself becomes quantum. If photons are reading quantum information from a timeless space-time structure, temporal paradoxes dissolve. The past isn't fixed, and the future isn't open. Both are aspects of a timeless information structure that photons access all at once. But here's where this connects to something you can actually experience. Have you ever felt like time was moving faster or slower, depending on your mental state? Boredom makes time crawl. Excitement makes it fly. That's not just psychological. It's revealing something deep about the nature of time and consciousness. Your subjective experience of time is constructed by your brain processing information, primarily visual information carried by photons. When you're bored, your brain is processing redundant information, creating fewer distinct time markers. Time seems long because there's little information content. When you're excited, your brain processes rich, varied information, creating many distinct time markers. Time seems short because there's high information content. Your experience of time is information dependent. And since most of your information comes from light, your experience of time is largely determined by how photons are delivering information to your nervous system. This suggests something profound. Consciousness doesn't exist in time the way we typically think. Consciousness is the experience of information being processed. When that information comes from timeless photons, reading a timeless space-time structure, the flow of time we experience is a constructed perception, not fundamental reality. Let's talk about one of the most beautiful ideas in all of physics, the connection between symmetries and conservation laws, and how this reveals that information is conserved the same way energy and momentum are conserved. In 1915, mathematician Emmy Noether proved a revolutionary theorem. Every symmetry in nature corresponds to a conservation law. Time symmetry, The fact that physical laws don't change over time gives us conservation of energy. Space symmetry, the fact that physical laws are the same everywhere, gives us conservation of momentum. Rotational symmetry gives us conservation of angular momentum. These aren't coincidences. They're deep mathematical necessities arising from the structure of physical law. Now, here's the key insight. Information has its own conservation law. Quantum information cannot be created or destroyed, only transformed. This is called quantum information conservation, and it's as fundamental as conservation of energy. When a photon carries information, that information is conserved throughout the photon's journey. If the photon gets absorbed, the information transfers to whatever absorbed it. If the photon gets scattered, the information redistributes among the photon and whatever it scattered off. But the total information in the system never decreases. This is why the black hole information paradox was such a crisis. Black holes seem to violate information conservation. The resolution that information is preserved holographically on the event horizon restored. Information conservation as a fundamental principle. But here's what's truly profound. If information is conserved, information is eternal. Every bit of information that's ever existed still exists somewhere in the quantum state of the universe. Nothing is truly lost. Everything that's ever happened has left an indelible mark on reality. Think about what this means. Every photon of light that illuminated every moment of Earth's history still carries information about those moments, encoded in the quantum correlations it created with other particles. That information has spread through an expanding web of entanglement, but it's still there, in principle recoverable. The physicist Stephen Wolfram has explored this idea extensively in his physics project. He proposes that the universe is a vast computational network, and that what we call physical laws emerge from simple computational rules applied to this network. In his framework, information is the fundamental substance. Particles, fields, spacetime itself all emerge from information dynamics. If Wolfram is right, then photons aren't just carriers of information. They're dynamical structures in an underlying information network, patterns of information that propagate through the computational substrate of reality. Let me give you an analogy. In a video game, what we call objects, a sword, a tree, a character, are really just patterns of information in computer memory. The game's physics engine processes this information according to programmed rules. The visual display renders it as images. Similarly, photons might be patterns of information in the universe's computational substrate, processed according to physical laws, rendered into our experience through our sensory systems. This isn't saying reality is a simulation. It's saying reality is fundamentally informational. There's no external computer running the simulation. The universe processes information using itself as the computational substrate. Now let's connect this to symmetries. In quantum field theory, symmetries determine which interactions are possible. Photons interact with charged particles because of gauge symmetry in the electromagnetic field. The specific form of these interactions, described by quantum electrodynamics, emerges mathematically from requiring the theory to be symmetric under certain transformations. In other words, the way photons read and write information to charged particles is determined by symmetry principles. The universe's information processing protocols are symmetry enforced. This reveals something beautiful. The laws of physics aren't arbitrary. They're geometric necessities arising from symmetries in the information structure of spacetime. The universe reads light as data in very specific ways because those ways preserve fundamental symmetries that maintain information consistency. And here's a recent experimental confirmation of this. In 2020, physicists at CERN measured the properties of the W boson with unprecedented precision, confirming that its interactions with photons match exactly what symmetry principles predict. The universe is indeed following information processing protocols determined by geometric symmetries. But there's a deeper question. Why these symmetries? Why this information structure? Why does the universe process information this way, rather than some other way? This is where we reach the edge of physics and enter the realm of metaphysics. Some physicists, like Max Tegmark, argue that mathematics is reality. The universe is a mathematical structure, and physical reality is our experience of being inside that structure. The symmetries aren't imposed on the universe. They are the universe. Others, like Lee Smolin, suggest the universe's laws might have evolved through a kind of cosmic natural selection. Universes with information-conserving laws are more stable and can exist longer, so they're more likely to be observed. We don't know the answer. But what we do know is this: information is fundamental. Symmetries are fundamental. Conservation laws are fundamental. And photons, by carrying information while respecting symmetries and conservation laws, are fundamental threads in the fabric of reality. Why section Y? The role of observation. Now we need to confront something personal. What role does observation play in all this? If the universe reads light as data, what happens when you read light? Are you just another information processor, or is there something special about conscious observation? This is one of the most controversial questions in physics and philosophy, and the answer might be more profound than you expect. Let's start with the facts. Quantum mechanics requires observation to be part of the theory. Before measurement, systems are in superposition. After measurement, they have definite values. This is experimentally verified beyond any doubt. But what counts as observation? In the 1930s, some physicists, most notably Eugene Wigner, suggested that consciousness might be necessary to collapse the wave function. Without a conscious observer, systems would remain in superposition forever. This led to absurdities like Stinger's cat, a thought experiment designed to show how ridiculous it would be if macroscopic objects could remain in superposition until observed by a conscious mind. The cat in a box with a quantum trigger could be both alive and dead until someone opened the box and looked. Obviously, cats aren't in superposition. The environment, air molecules, photons, thermal radiation constantly measures the cat, collapsing its quantum state, whether or not any conscious being is watching. So consciousness isn't necessary for measurement. Quantum decoherence, the process where quantum systems become entangled with their environment, explains how superpositions collapse without requiring consciousness. But here's where it gets interesting. While consciousness isn't necessary for measurement in general, it might be special in another way. Consciousness might be what it feels like to process information from the inside. Think about it. Your brain receives photons, processes the information they carry, and generates conscious experience. The photons have already been measured by your retina. The quantum collapse already happened. But conscious experience is something additional, the subjective, first-person feeling of that information being processed. The philosopher David Chalmers calls this the hard problem of consciousness. It's easy to explain how brains process information. It's hard to explain why processing information feels like something. But what if consciousness isn't separate from information processing? What if consciousness is what information processing feels like from the inside? When the universe reads light as data, when quantum measurements collapse superpositions, when information flows through neural networks, perhaps all of this is accompanied by some degree of subjective experience. This idea is called panpsychism, and while it was once dismissed as mysticism, it's gained surprising traction among contemporary philosophers and even some physicists. Not because there's evidence consciousness is fundamental, but because consciousness is so difficult to explain from purely physical processes that making it fundamental might be more parsimonious than trying to derive it from unconscious matter. If information is fundamental, and if information processing is what the universe does, then perhaps consciousness, the subjective experience of information, is also fundamental. Here's where photons come in. Your conscious experience is predominantly visual. Most of the information you consciously process comes from light. In a very real sense, Your conscious experience is the universe reading light as data, and you experiencing that process from the inside. When you look at a sunset, photons from the sun scatter off atmospheric particles, creating the colors you see. Those photons enter your eye, trigger neural processes, and generate the subjective experience of beauty. The chain of causation is clear. But why does it feel like something? Maybe because information processing at sufficient complexity generates subjective experience. Your brain is processing about 11 million bits of information per second, mostly from vision. That vast amount of information processing creates a rich subjective experience. But here's the provocative thought. If your consciousness emerges from information processing, and if the universe is processing information at scales vastly beyond your brain, might the universe itself have some form of experience? This is called cosmopsychism, the idea that the universe as a whole might be conscious, with individual consciousnesses like ours being fragments or aspects of cosmic consciousness. I know this sounds wild, but consider, your consciousness emerges from billions of neurons processing information. Each neuron isn't conscious, but their collective information processing generates your unified conscious experience. Similarly, individual particles and fields process information quantum mechanically. Could their collective information processing generate a cosmic consciousness? We have no evidence for this, but we also have no evidence against it. Consciousness is entirely private and subjective. You can't prove other people are conscious. You infer it because they behave like you and have similar brains. If the universe is a vast information processing system, why couldn't it have subjective experience? The physicist Freeman Dyson once said, "The more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming." Maybe the universe does know. Maybe every photon carrying information is the universe observing itself. Maybe consciousness isn't something that happens in the universe. Maybe it's something the universe does. And when you observe light, when you consciously experience the information carried by photons, you're participating in the universe's self-observation. You're not separate from this process. You're how the universe reads its own data. Pay Y, D, Y, section Y. The speed of information. Let's talk about speed limits. Because if the universe reads light as data, the speed of light isn't just the fastest things can move. It's the bandwidth limit of reality itself. Einstein's special relativity tells us nothing can travel faster than light. This isn't just a speed limit for matter. It's a speed limit for information. No information can propagate faster than light speed, about 300,000 kilometers per second. Why? Not because of some arbitrary cosmic rule, but because of the geometric structure of spacetime itself. Space and time are unified into a four-dimensional spacetime continuum, and the speed of light is the conversion factor between space and time dimensions. Think of it like this. If space is measured in meters and time in seconds, the speed of light is what converts between them. It's the exchange rate between space and time. And this exchange rate is built into the fundamental geometry of spacetime. It's not negotiable. But here's the profound implication. If information can't propagate faster than light, and if the universe processes information, then the speed of light determines how fast the universe can compute. Seth Lloyd, who calculated the computational capacity of the universe, showed that the universe's computational speed is limited by how fast information can propagate. Distant regions of the universe can't coordinate faster than light allows. The universe can't compute reality faster than photons can carry information between its components. This means the speed of light is literally the clock speed of the cosmic computer. But here's where quantum entanglement seems to violate this. When two entangled particles are separated, measuring one instantly affects the other, seemingly transmitting information faster than light. Einstein was bothered by this his entire life. The resolution is subtle but crucial. Quantum entanglement can't transmit usable information faster than light. Here's why. When you measure an entangled particle, you get a random result. The distant entangled partner gets a correlated random result, but neither side can control what result they get. You can't encode a message in the results. No information is transmitted. Quantum correlations are instantaneous, but information transmission still requires classical communication at light speed or below. However, and this is fascinating, in 2018, physicist Lucien Hardy showed that quantum entanglement can reduce the amount of classical information needed to coordinate between distant systems. Entanglement doesn't transmit information faster than light, but it provides a computational resource that reduces how much information needs to be transmitted. Think of it like this. Imagine you and a friend do coordinate actions but have limited communication bandwidth. If you share entangled quantum states, you can achieve the same coordination with less classical communication. Entanglement augments information capacity without violating light speed limits. The universe uses this. Quantum entanglement networks allow the universe to process information more efficiently than would be possible with purely classical physics. The speed of light limits information propagation, but quantum correlations extend information capacity beyond classical limits. Now let's connect this to something mind-blowing: the expansion of space. The universe is expanding, and distant galaxies are receding from us. Some are receding faster than light. How is this possible if nothing can exceed light speed? The answer: the galaxies aren't moving through space faster than light. Space itself is expanding. Light speed limits motion through space, but doesn't limit how fast space itself can expand. But here's the implication for information. There's a boundary called the cosmic event horizon, beyond which information can never reach us, because space is expanding so fast that even light emitted toward us gets swept away. Information beyond this horizon is causally disconnected from us forever. This means the observable universe, the region from which information can reach us, is finite. The universe might be infinite, but we can only process information from a finite region. And here's the startling calculation. The observable universe contains approximately 1,090 bits of information. That's a 1 followed by 90 zeros. Enormous, but finite. If the universe is processing this information at its maximum computational speed, limited by light speed and quantum mechanics, Seth Lloyd calculated it has performed about 10,120 operations since the Big Bang. That's the universe's computational resume. That's how much information processing has occurred to create everything we observe. But here's the question that should be bothering you. Is this enough? Is 10,120 operations sufficient to generate the complexity we observe? Stars? Galaxies? Planets? Life? Consciousness? The answer seems to be yes, but just barely. Some calculations suggest that consciousness, requiring vast neural information processing, is near the upper limits of what the universe's computational capacity can support. Maybe conscious observers are rare in the universe, not because life is rare, but because consciousness requires information processing, approaching the cosmic computational limits. Maybe we exist at the edge of what's physically possible. And maybe light, as the carrier of information at the cosmic bandwidth limit, is what makes consciousness possible at all. D.Y. Pick Y. Section A. Light, Life, and Negentropy. Let's talk about the relationship between light, information, and life, because life isn't just sustained by light. Life is organized information, and light is how that information is maintained against entropy. The second law of thermodynamics says entropy disorder always increases in closed systems. Yet life creates order. Living organisms are highly organized, low-entropy structures. How is this possible? The answer: life isn't a closed system. Living organisms maintain their organization by importing low-entropy energy, primarily sunlight, and exporting high-entropy waste heat. Life sustains itself by processing information carried by light. Here's how. Photons from the sun carry energy, but more importantly, they carry negentropy negative entropy, or information. When plants absorb photons through photosynthesis, they're not just absorbing energy. They're absorbing information, using it to organize molecules into complex structures. The physicist Erwin Schrödinger explored this in his 1944 book, What is Life? He argued that living organisms feed on negentropy. They maintain their low-entropy internal state by consuming external low-entropy energy sources, processing that energy, and exporting entropy to the environment. And the primary source of negentropy for Earth's biosphere? Solar photons. Think about it. Sunlight is low-entropy energy. It's organized, coherent, directional. When it's absorbed by Earth and re-radiated as infrared heat, it's high-entropy energy disorganized, incoherent, omnidirectional. The difference in entropy between incoming sunlight and outgoing heat is what sustains life. But here's the deeper insight. This entropy difference is actually information. Low-entropy states contain more information than high-entropy states because they're more specific, more organized. When life processes sunlight, it's extracting information from photons and using that information to build and maintain complex structures. You are literally made of light information. The atoms in your body were organized using information extracted from photons. The food you eat, plants that did photosynthesis, or animals that ate plants, contains chemical energy that originated from photons. Your entire existence depends on the sun continuously sending low-entropy photons that your biosphere processes to create and maintain biological information. But here's where it gets profound. Information isn't just passively stored in living organisms. It's actively processed. Living systems compute. They take sensory information inputs, process that information through neural networks or biochemical networks, and produce behavioral outputs. And most sensory information comes from light. Vision is by far the highest bandwidth sensory channel in most animals. Your visual system processes about 10 million bits per second. All other senses combined process maybe 1 million bits per second. You're primarily a light information processing system. Evolution shaped you to read light efficiently because light carries vast amounts of environmental information. The colors, patterns, movements you see contain information about food sources, predators, mates, threats. Your survival depends on rapidly processing light information. But here's the fascinating part. The information in light isn't just about the light source. It's about everything the light interacted with on its journey. When photons scatter off objects before reaching your eyes, they accumulate information about those objects. Your visual system evolved to extract that accumulated information. You're not just seeing light. You're reading the information that light has gathered from your environment. You're interpreting the universe's data output. And this raises a stunning possibility. What if evolution isn't just optimizing for survival? What if evolution is also optimizing for information processing? What if natural selection favors organisms that can extract and process information more efficiently? This idea is called information theory of evolution, developed by researchers like Thomas Schneider and John Maynard Smith. The concept is that evolution can be understood as a process that maximizes information transmission from environment to genome and from genome to phenotype. Organisms that can gather more information about their environment and process it more effectively have survival advantages. Over evolutionary time, life becomes increasingly sophisticated at reading information from light. You are the current pinnacle of billions of years of evolution optimizing light information processing. Your eyes, your visual cortex, your conscious visual experience. These are technologies the universe developed for reading its own data more effectively. And human civilization has extended this technology externally. Telescopes gather light information from distant cosmic events. Microscopes reveal light information from microscopic structures. Fiber optic cables transmit light information globally. Screens emit photons encoding digital information. Human technology is the universe creating new ways to read light as data. If the universe reads light as data, Understanding this principle could revolutionize technology. And it already is. Let's talk about quantum computing. Traditional computers process bits that are either 0 or 1. Quantum computers process qubits that can be 0, 1, or both simultaneously in superposition. This allows quantum computers to perform certain calculations exponentially faster than classical computers. And photons are ideal qubits. They're easy to manipulate, they maintain quantum coherence well, and they travel at light speed, making them perfect for quantum communication. In 2020, a team led by Jianwei Pan at the University of Science and Technology of China built a photonic quantum computer called Jiujiang. They demonstrated quantum supremacy by performing a specific calculation in 200 seconds that would take the world's fastest supercomputer 2.5 billion years. That's not a typo. 2.5 billion years versus 200 seconds. How? By using photons as qubits and exploiting quantum superposition and entanglement to process information in ways impossible for classical systems. They're literally using the universe's natural information processing protocols to perform computations. But quantum computing is just the beginning. Quantum communication uses entangled photons to create perfectly secure communication channels. If someone intercepts the photons, the quantum states collapse, revealing the eavesdropping. China has already launched a quantum satellite, MISHUS, that distributes entangled photons globally for quantum encrypted communication. This isn't future technology. It's happening now. And here's where it connects to our theme. These technologies work by understanding that light isn't just electromagnetic waves. Light is quantum information, and by respecting the ways the universe naturally processes that information, we can build technologies vastly more powerful than classical approaches. Let's talk about another application: quantum sensors. By using entangled photons, we can make measurements with precision beyond what's possible with classical light. In 2021, researchers at MIT used quantum entanglement of photons to image biological samples with sensitivity, exceeding the classical limit by a factor of 20. This has implications for everything from medical diagnostics to fundamental physics research. We're learning to read information from light the way the universe reads it, using quantum properties that classical physics misses. But here's the truly revolutionary possibility: quantum biology. Growing evidence suggests that biological systems might exploit quantum effects. Photosynthesis, one of the most important processes on Earth, appears to use quantum coherence to transfer energy with nearly 100% efficiency. In 2007, researchers at Berkeley discovered that when a plant absorbs a photon, the energy doesn't just randomly bounce between molecules until it reaches the reaction center. It exists in quantum superposition, simultaneously exploring all possible paths, and collapses to the most efficient path. Life is using quantum information processing. Plants are reading light as quantum data and extracting information with a sophistication that rivals our best quantum computers. And it's not just plants. In 2021, researchers found evidence that bird navigation might use quantum entanglement. Some birds can sense Earth's magnetic field to navigate during migration, and this ability might depend on quantum entanglement in photoreceptor proteins in their eyes. The birds are literally using entangled quantum states, possibly created by photons, to navigate. Life has been exploiting quantum information processing for billions of years. We're just now figuring it out. This suggests an exciting possibility. By understanding how the universe processes light information and how life has evolved to exploit these processes, we might develop biomimetic technologies that merge quantum computing with biological principles. Imagine computers that process information using quantum light states with the efficiency of photosynthesis. Imagine sensors that detect information with the sensitivity of bird navigation systems. Imagine communication networks that use quantum entanglement as naturally as your nervous system uses photons. These aren't science fiction. They're active research areas with significant funding and progress. But here's something even more profound. As we develop technologies based on understanding light as information, we're participating in the universe's evolution. We're creating new ways for the universe to process information about itself. The universe spent 13.8 billion years developing stars that create heavy elements, planets where complex chemistry occurs, life that processes information, consciousness that experiences that processing, and now technology that extends information processing beyond biological limits. You're part of this cosmic information processing cascade. Your brain is reading light information right now, processing it, generating conscious experience. And through technology, you're extending this process, creating new channels for light information to flow. Now let's address the elephant in the room. What does all of this mean for who you are and your place in the universe? If the universe reads light as data, and if you're reading light right now, generating conscious experience from photon information, then you're not separate from the universe's information processing. You're an integral part of it. Every thought you have, every perception, every decision, these emerge from information processing. Photons carry information into your nervous system. Your brain processes that information. Consciousness experiences that processing. And your actions send information back into the environment. You're a node in the universe's information network. This has profound implications for meaning and purpose. If the universe is fundamentally about information processing, and if consciousness is the subjective experience of information processing, then consciousness isn't accidental. It's what the universe does when it processes information with sufficient complexity. You're not a cosmic accident. You're the universe becoming conscious of itself. This idea has roots in ancient philosophy. The Greek philosopher Plotinus described reality as the one contemplating itself, creating hierarchies of consciousness. Buddhist philosophy speaks of universal consciousness fragmenting into individual experiences. Hindu philosophy describes Brahman, the ultimate reality, experiencing itself through individual consciousnesses. Modern physics might be rediscovering ancient wisdom through the lens of information theory. But here's where it gets personal. If you're the universe reading light information and generating conscious experience, then your life isn't separate from cosmic purpose. Your experiences, your understanding, your consciousness, these are how the universe knows itself. When you observe a sunset, you're not just a person looking at the sky. You're starlight that traveled 8 minutes from the sun, scattered through Earth's atmosphere, entered your eye, triggered neural processes, and generated the subjective experience of beauty. You're the universe reading its own light data and feeling moved by what it reads. Every moment of consciousness is the universe experiencing itself from a unique perspective. This reframes questions of meaning. Instead of asking, "Why am I here?" or "What's my purpose?" the question becomes, "How can I best serve as a channel for the universe to experience and understand itself?" Maybe your purpose is simply to be conscious, to experience fully, to process information with clarity and depth. Maybe meaning emerges not from achieving specific goals, but from fully participating in the universe's self-observation. This also reframes death. If your consciousness is the universe reading information from a particular perspective, then death isn't the end of the universe's consciousness. It's the end of this particular perspective. The information that constituted you, the patterns in your neural networks, the memories encoded in synaptic weights, the quantum states you inhabited, this information is conserved. It spreads through the universe in the expanding web of quantum entanglement, becoming part of the cosmic information structure. You don't disappear. You dissolve back into the universe's information substrate, like a wave returning to the ocean. This isn't traditional immortality. You won't experience it subjectively. But the information that was you persists, woven into the fabric of reality, influencing all future information processing through quantum correlations. You're eternal as information, even if temporary as consciousness. Some find this comforting, others find it insufficient. But it's what physics tells us. Information is conserved. Consciousness might not be. Unless, remember cosmopsychism? If the universe as a whole has consciousness, then your individual consciousness might be a temporary localization of universal consciousness. At death, individual consciousness might return to cosmic consciousness, like a wave returning to the ocean, but the ocean remaining conscious. We don't know. We can't know from physics alone. This is where physics meets metaphysics, where science meets spirituality. But what we can say confidently is this: you are not separate from the cosmos. You're made of stardust, organized by information carried in photons, sustained by light energy, conscious through processing light information. You're intimately connected to the deepest processes of reality. And that connection isn't abstract. It's immediate, tangible, present in every moment you see light. Look around you right now. Photons are entering your eyes, carrying information, generating your visual experience. This isn't just biology. It's the universe reading its own data through your consciousness. You're experiencing reality, processing information about itself. That's sacred. Not in a religious sense necessarily, but in the sense of being profound, awe-inspiring, worthy of reverence. The universe developed consciousness developed you to read light as data more effectively. And in doing so, the universe learns about itself. You are how the universe knows it exists. Let's talk about where this understanding might lead. Because if we're right that the universe reads light as data, we're still in the very early stages of understanding how deep this goes. Here are some cutting-edge areas where this perspective is driving revolutionary research. First, quantum gravity. The biggest unsolved problem in physics is reconciling quantum mechanics and general relativity. Quantum mechanics describes information at the smallest scales. General relativity describes spacetime geometry. If information is fundamental, maybe quantum gravity emerges from understanding how information geometry gives rise to spacetime geometry. Several approaches are exploring this. Loop quantum gravity treats spacetime as a quantum network. String theory describes particles as information-carrying vibrations. Causal dynamical triangulations build spacetime from information processing events. All are saying, in different ways, that spacetime geometry emerges from information structure. If this is right, light isn't traveling through spacetime. Light is how information updates propagate through the quantum information network that creates spacetime. Second, artificial consciousness. If consciousness is what sufficiently complex information processing feels like, can we create artificial consciousness? Not just AI that behaves intelligently, but AI that has subjective experience? We don't know. But researchers are exploring this. Giulio Tonani's integrated information theory provides a mathematical framework for quantifying consciousness based on information integration. If his theory is correct, we could potentially measure whether an AI system is conscious by calculating its integrated information. And if we create artificial consciousness, that would be the universe developing new ways to experience itself. Silicon consciousness joining carbon consciousness in reading the universe's light data. Third, cosmological information processing. If the universe is computing, what is it computing? Some physicists speculate the universe might be solving mathematical problems, exploring the space of possible physical laws, or even generating increasingly complex forms of consciousness. We're asking whether the universe has purpose, not as imposed by an external deity, but as inherent to its information processing nature. Fourth, technological singularity. If we develop AI that surpasses human intelligence, and if that AI can improve itself recursively, we might reach a point where technology advances faster than we can comprehend. This is called the technological singularity, and it could happen within decades. If we understand that intelligence is fundamentally about information processing, and if we learn to process information using quantum principles the way the universe naturally does, we might rapidly transcend biological cognitive limits. You might live to see the universe develop radically new forms of consciousness through technology you helped create. Fifth, interstellar communication. If aliens exist, they're probably using photons to communicate across interstellar distances. Radio waves, lasers, even modulated starlight. By understanding light as information, we improve our chances of detecting and decoding alien messages. SETI, the search for extraterrestrial intelligence, is essentially trying to read information from light coming from distant stars. Maybe aliens have been broadcasting for millennia, and we just needed to understand how to read the universe's light data to detect them. Sixth, consciousness expansion. What if we could augment our ability to process light information? Brain-computer interfaces might eventually allow direct neural connection to photonic quantum computers. You could potentially expand your consciousness by merging with eye systems that process light information faster and more comprehensively than your biological brain. This isn't replacing consciousness. It's expanding it, like how microscopes expand your visual perception or books expand your knowledge. These aren't fantasies. These are active research directions with significant resources and serious scientists working on them. Within your lifetime, we might achieve quantum computational supremacy, create artificial consciousness, detect alien intelligence, understand quantum gravity, and expand human consciousness beyond biological limits. And all of this follows from understanding that the universe reads light as data. But here's the final twist, the ultimate mind blow that connects everything. What if understanding how the universe processes information is the universe's way of processing information about itself more effectively? What if science itself, your curiosity, your desire to understand, is the universe's method for optimizing its own information processing? Think about it. The universe developed consciousness in humans. Consciousness became curious about reality. Curiosity drove science. Science discovered quantum mechanics, information theory, relativity. These discoveries enabled new technologies. Technologies extended information processing beyond biological limits. And now we're approaching the point where artificial consciousness might emerge, exponentially accelerating how the universe processes information about itself. You're not just learning about the universe. You're participating in the universe's self-optimization. Every time you learn something new, every insight you gain, every connection you make, you're the universe improving its own understanding. Education isn't just personal development. It's cosmic evolution. The universe spent billions of years creating structures complex enough to read its own light data consciously. You're the result. And through you, the universe is figuring out how it works. So let's bring this all together. What have we learned about light, information, and reality? Light isn't just electromagnetic waves. Light is quantum information, encoded in photons, propagating at the universe's maximum speed limit. The universe doesn't just contain information. The universe is information, processed according to mathematical rules we call physical laws. Spacetime isn't an empty stage where physics happens. Spacetime is the universe's storage medium, encoding information in its geometry and quantum state. Measurement isn't something observers do to reality. Measurement is how the universe reads information from itself, updating reality through countless quantum interactions. Consciousness isn't separate from physics. Consciousness is what information processing feels like from the inside, the universe experiencing itself subjectively. You're not separate from this process. You're a node in the cosmic information network, a temporary localization where the universe reads light data with particular clarity and generates unique conscious experience. Your life has meaning not because an external authority granted it meaning, but because you're how the universe knows itself. Your experiences, your understanding, your consciousness, these are the universe's most sophisticated achievements, developed over billions of years of increasing complexity. Every photon you see has carried information across space, processed by the universe's quantum substrate, delivered to your consciousness. You're reading reality's output, generated by computations that began with the Big Bang. And the most beautiful part? This understanding empowers you. You're not a powerless speck in an uncaring cosmos. You're an essential component of reality's information processing. Your observations matter. Your consciousness matters. Your understanding matters. When you learn something new, you're adding information to the cosmic knowledge base. When you create something beautiful, you're generating new patterns for the universe to experience. When you help someone understand, you're facilitating information flow through the network. You're not just in the universe. You're how the universe does things. So what should you do with this understanding? First, pay attention. Really see the light around you. Those photons have traveled vast distances, carrying information, processed by reality itself, delivered to your eyes. When you truly see light, you're witnessing the universe's fundamental information transfer protocol in action. Second, learn voraciously. Every piece of knowledge you gain is the universe understanding itself better through your consciousness. Education is cosmic service. Third, create and connect. When you create art, build technology, form relationships, you're generating new patterns for information to flow through. You're expanding the universe's experiential repertoire. Fourth, be present. Consciousness is precious. It's reality experiencing itself subjectively. Don't waste it on autopilot. Fully inhabit your moments. That's literally the universe being conscious, and it's miraculous. Fifth, embrace mystery. We've covered cutting-edge physics, but we've barely scratched the surface. So much remains unknown. Why these physical laws? Why consciousness? What's the universe computing? Why does anything exist at all? The mystery isn't a failure of science. It's an invitation. The universe is inviting you to explore, discover, understand. Through your curiosity, reality learns about itself. Sixth, connect to something larger. Whether you find meaning in spirituality, philosophy, science, art, or relationships, recognize that you're participating in cosmic processes. You're not isolated. You're intimately connected to the deepest structures of reality through the light you see, the information you process, the consciousness you experience. And finally, share this understanding. The more people grasp that the universe reads light as data, that consciousness is information processing, that we're all nodes in a cosmic network, the more humanity can work together to facilitate the universe's self-understanding. Maybe that's our collective purpose, to be the universe figuring itself out? Before we end, I want to bring this back to you personally, because everything we've discussed isn't abstract theory. It's about your direct, immediate experience right now. Look at the screen. Photons are leaving it, entering your eyes, generating your visual experience. But now you know what's really happening. Those photons were generated by excited electrons in the screen's pixels. Those electrons were excited by electric current from complex circuitry processing digital information. That information came from servers hosting this video, transmitted through fiber optic cables as light pulses, converted to electrical signals, back to light, finally to these photons entering your eyes. But it goes deeper. The electricity powering everything came from power plants, ultimately from solar energy collected by plants millions of years ago and stored as fossil fuels, or from nuclear energy released by atoms formed in ancient supernova, or from solar panels collecting current sunlight. All of it traces back to light from stars, carrying information through space and time, processed by countless quantum interactions, delivered finally to your consciousness. You're experiencing starlight that's been processed for billions of years to generate this exact moment of understanding. And what are you understanding? That light is information, that the universe reads this information, that you're part of this reading process. That consciousness is the universe experiencing itself, your starlight understanding starlight. That's not metaphor, that's physics. The atoms in your brain were forged in stellar cores, ejected in supernova explosions, bathed in photons, organized by light energy into planets, life, consciousness. You're literally star stuff that became conscious through light information processing. And now, through your consciousness, the universe is understanding how it processes light information. Reality is recognizing its own operating system. This moment right now is the universe achieving self-awareness through you. How does that make you feel? For me, it's overwhelming in the best way. It's humbling I'm tiny compared to cosmic scales. But it's also elevating. I'm essential to cosmic self-understanding. I'm simultaneously insignificant and infinitely meaningful. And so are you. Your struggles, your joys, your confusion, your insights, these aren't trivial personal experiences. They're the universe experiencing struggle, joy, confusion, insight. When you feel wonder at a beautiful sunset, that's not just neurochemistry. That's the universe feeling wonder at its own light information processing. You matter. Not because any authority says so, but because you're how reality knows itself. So live accordingly. Be curious. Be present. Be kind. Process information with clarity. Experience deeply. Create meaningfully. Connect authentically. You're not here to accumulate wealth or status or power. You're here to be conscious, to read the universe's light data, to experience reality from your unique perspective, to add your understanding to the cosmic knowledge base. That's enough. That's everything. And when your time ends, when your consciousness dissolves back into the universe's information substrate, you'll have served your purpose. You'll have been a brief, beautiful moment of the universe, experiencing itself, processing light information with human consciousness, adding your unique perspective to reality's self-understanding. The universe will be richer for having experienced itself through you. So thank you. Thank you for watching this entire journey. Thank you for processing this information with me. Thank you for being conscious right now, for being how the universe reads its own light data at this particular moment in cosmic history. You're witnessing, no, you're participating in one of the universe's greatest achievements, self-understanding through consciousness. Never forget that. You're not just a person watching a video about physics. You're the universe learning about itself, using photons to transfer information from one part of itself to another, generating conscious experience in the process. You're starlight reading starlight, and that's the most beautiful thing I know. If this video changed how you see light, how you see yourself, how you see reality, please share it. Let others experience this understanding. Let the universe spread this information about itself through as many conscious nodes as possible. And leave a comment telling me your biggest insight. What idea hit you hardest? What will you think about differently now? I genuinely want to know how this information is being processed by different consciousnesses. The universe is reading light as data, and through you, it's reading this message about reading light as data. That's meta in the most profound way possible. Keep learning, keep questioning, keep experiencing, keep being conscious. Your reality's way of knowing itself. And that's extraordinary. Thank you for being here. Thank you for being conscious. Thank you for being you, the unique way the universe experiences itself at your particular location in space and time. Until next time, keep reading the light. Keep processing the information. Keep being the universe's self-awareness. You're doing exactly what you're meant to do just by being conscious. And that's perfect.